graph number 1 has been squeezed, and graph number 2, this one is stretched. So therefore, giving the difference between the two, we can say that, so this is still from the center of distribution, so squeezed towards, squeezed away from, so this, or maybe stretched away from, so this first graph is going to give us what we call close dispersion, while the other one is going to give us a wide dispersion. So the extent of stretching of these two particular curves gives the concept of what we call dispersion. That's the difference between the two. So therefore, if we try to look at the two concepts that we've discussed about, that is how far apart data points lie from each other and the extent to which a distribution is stretched. Therefore, it's going to assist us interpret this concept of the mean absolute deviation. Now that from our first video for the statistics, of course, for variability and dispersion, that we had given the concept of a range, we gave this set of data that assisted us in finding the range for the largest and the smallest value. And still I'm going to write so that it is able to assist us understand to this concept of the mean absolute deviation. So the last one is 84. And we said that we can give range by finding the difference between the largest value, that was 102, minus the smallest value, that was 10, and we got our range of 92. Now in this case, range does not of course tell us much about the characteristics of observations or of the data that is lying within the interval that is containing the range. This is the interval that is containing the range. So therefore, we are going to use the mean to find other characteristics of the observations at the exact, or maybe at the center of the data distribution that we have given using the two graphs that we have illustrated. So this is the center of distribution for this range of data for the frequency. And this, we see that this center, we call it the mean. So for that case, range is going to give us, range does not give us much information about the data that is in between this range of values, but we are going to use the mean, characteristics of the mean, in order to find other information of that set of data. So therefore, the range that is defining the extents of both ends, of course, as we have said, as it doesn't give us much information. Now the mean absolute deviation is going to give us a more enlightened view of that specific range of data. Now in this case, we are going to use this as a measure of variability as well, the mean absolute deviation as a measure of variability. And I'm going to use an illustration of a specific range of data in order to find out how we can be able to compute the mean absolute deviation. So in summary form, I've said that this one gives us a narrow range of information. So we are going to use the characteristics of the mean and the, of course, the mean and the range in order for us to find characteristics of the data that lies in between that range. And this is the mean absolute deviation, and there's another concept that we're going to call the mean square deviation. Of course, the two concepts are going to assist us in interpreting the characteristics of those specific set of data. So I'm going to do away with this one so that I can use a graph to illustrate the points that we have talked about. Now, from the graphical illustrations that are given concerning the concept of the variability and the dispersion, I said that both of these figures are characterized or defined from the deviation or a stretch or squeeze away from or towards the center of a distribution. and we refer to this center as the mean. So therefore, when we talk about the term deviation or dispersion, this is the range in which, or the deviation, this is the range in which a value goes away or moves towards the center of distribution. So this graph that I've given in table B is going to assist us to try and figure out. So if we have these values as 10, and then the difference between, of course we are given this symbol to represent the mean, that is the summation, of course we have said from I to n of the frequency times the range of data, then the summation from I to n of the frequency. So this is how we have defined the mean from our first video on statistics. So if we define mean this way, then the difference between this range of data, that is x and xi, therefore is the difference between this and the mean. So if you try to find the the mean, our mean for this, it's going to be, of course, the summation of all these values, which is going to be 54. Yes, this is 25, 31, 41 plus 11. No, just do an addition. This is 25 plus 18. This is 3, 4 plus 11. Okay. The summation for this first column, which is a range of our values, is going to give us 54. And then the summation of the frequency, of course, in this case, the frequency is going to be 1. They're appearing once. So we are going to have 1, 2, 3, 4, 5. So the frequency is going to be 5. Therefore, our mean is going to be 10.8. So in this case, if our mean is 10.8, then these values can be obtained by finding the difference between x. For instance, for the first one, we're just going to do an illustration for the first one, and that is the same concept that is going to apply to the rest. So we're going to find it's 10 minus 10.8, which is a minus 0.8. So this is how we find this particular deviation, which is a negative one. Now for the second one, third, fourth, fifth, respectively, these are the values for that column. Now for absolute deviation, the concept absolute means that's a positive value, and it is indicated using these symbols. So suppose I say that is x, and the absolute value for x is given as this. So therefore, the absolute value for that deviation is going to be a positive value, which is, of course, the positive value for the second columns. And then we are going to have this one squared, which is deviation squared. Therefore, as we have said, we've got the mean, which is 10.8. We can find the mean absolute deviation, using this formula. So we have the mean absolute deviation will be given as the summation of f using these absolute values divided by the summation of f. Of course, in this case, this range of data for us is going to give us 11.2 divided by the summation of frequency. We have used 5 for us, our first case there. So it's going to give us 2.24. And that one will form what we call the mean absolute deviation. And this together with another concept, which is a mean square deviation, that we are going to do, in fact, immediately after this. They are going to give us more information about the data that we have talked about, which is spread in between the range, that is the smallest and the largest value. So in that case, we are going to look at the second concept now that we have defined this, which is the mean square deviation. This is the mean square deviation. So for that case, we have another column that I've listed on the data side. this is actually the square of these absolute values that are in between there. So the mean square deviation is given as the summation of x bar squared divided by n. So in that case, n still represents the total number of frequencies. So that is going to give us 42.4. So the summation of this is going to give us 42.4 divided by 5, which is 8.48. So if you try to look at these different concepts that we have talked about the range, which is the smallest and the largest value, the mean absolute deviation and the mean square deviation, of course, is going to assist us to measure what we call variability. So these two concepts are going to assist us to measure variability, and in that case, of course, try to interpret the extent of dispersion of the data, range of data that we have been given. So in this case, of course, this is a concept that we're also going to encounter in other areas of statistics, apart from this and the one that we have talked about, the mean or the measures of central tendency. We're going to match all of them in order to come up with different ways in which we're going to treat different statistical data that we may come across. So in that case, I'm going to stop there for today. I hope that this is going to assist us, of course, understand the concept of two insofar as variability and dispersion are concerned. So that is it for today. Thank you. Bye. God bless.